Welcome to AR Adventures, the journey of designing an augmented reality app for preschoolers' spatial learning. The presenters today are myself, Jillian Orr from GBH, Ashley Lewis-Presser from EDC, Louise Flannery from GBH, and Emily Bram from EDC. Augmented reality, or AR, is an evolving technology that may have great potential as a learning tool. Our team is exploring the potential of AR and the current limitations of the technology for fostering young children's spatial learning, specifically in preschool classroom environments. With funding from the National Science Foundation, our collaborative team of public media producers and curriculum designers from WGBH Educational Foundation, or GBH, and researchers from Education Development Center, or EDC, have iteratively developed an AR tablet app for preschoolers through a design-based implementation research (DBIR) approach. This showcase will share background information, the team's development journey, some of the design challenges we experienced, the design principles that resulted from those challenges, and the final AR app. We'll start with a little bit of background information.
Spatial learning is often neglected during the preschool years, despite its connection to later mathematics success. Spatial learning at the preschool level includes spatial reasoning, spatial navigation, and spatial representations. Spatial reasoning focuses on spatial relationships and using spatial vocabulary. Spatial navigation involves using maps and diagrams to plan, describe, and follow paths. And spatial representations involve developing that initial idea that real-world objects or locations correspond to a visual representation of that location or object on a map, diagram, or model.
AR technology layers virtual objects and characters on top of a device's camera view of the real world. Both AR virtual objects and the real world can be seen on screen at the same time, augmenting the user's perspective of the real world. Users can move around the real space to view the anchored AR objects and can interact with them in limited ways, which we will discuss later.
Given the affordances of AR technology, there may be potential to leverage it to foster young children's spatial learning. However, AR experiences must be tailored to the unique needs of preschoolers and factors within the preschool classroom environment, and thoroughly explored to ensure that the experience is truly supporting young children's healthy development and learning. To do this, our cross-disciplinary team started with a blueprint for the spatial learning goals and design principles. We engaged in a series of research studies and used that feedback and the findings from preschool teachers, children, and families to guide our iterative revisions of the activities.
Through this process, we developed the Gracie Friends AR Adventures iPad app.
Our design and development journey began with a strong need to support children's spatial learning and with strong potential, new AR technology that can overlay virtual images onto the view of a real-world space. Our team engaged in DBIR and conducted multiple rounds of iterative development to design the AR app. We worked closely with preschool educators, hosting focus groups, interviews, and testing out iterations of the AR app with preschoolers in the classroom.
We did 3 separate studies with different iterations of the app. In our first study, we conducted a formative user test with a prototype of the app to obtain feedback from preschool educators, parents, and children. The app was revised in preparation for a pilot study and then revised in preparation for and tested again in a comparison study. These 2 studies were completed in preschool classrooms with preschool educators and children. After the comparison study, we made more revisions before publishing the final version of the app. Our observations of children's play with the AR app were conducted in person, and we recorded children's gameplay using a head-mounted GoPro camera so that we could analyze videos by seeing the child's perspective.
The team's final AR app leverages GBH's popular digital series, Early Math with Gracie and Friends. The AR Adventures app will include 2 AR games guided by the Gracie character and her robot friend, Tulip. In one AR experience, children digitally pick apples from trees and feed them to farm animals, while also practicing spatial vocabulary and following spatial directions. In another AR experience, children visit an AR fair and fill in a digital map showing the placement of landmarks or rides at the fair. In both experiences, all the objects and characters children interact with are digital objects seen on screen. The app uses a billboarding approach in its design of AR objects, which allows us to use the 2D style of the Gracie Friends brand. Billboarded images are rotated to face the player at all times, giving the appearance of three-dimensionality with a 2D image. This is often used in 3D video games for distant background objects such as trees or grass, or other objects that could reasonably appear the same from any angle. In our designs, we have used this technique for all AR objects with the idea that players are in the center of a circular AR environment.
Throughout our journey, we experienced many design challenges that through our iterative process led to design principles. We'd like to share some of those with you here. Challenge 1. New, unintuitive technology. We found that AR technology is still very new for preschool children and educators, especially as a learning tool. Setting up AR scenes was often unintuitive and frustrating for children, and children needed support in learning how to hold the tablets to set up the AR scene. This resulted in our first design principle: provide intuitive and supportive tutorials and scaffolds that allow for young children's clear and easy setup and use of AR technology. For example, we added a visual scaffold showing children that they needed to hold the iPad upright in front of them, which would allow for a smoother AR scene setup experience.
Challenge number 2, AR setup. Several different technical approaches to establishing the AR scenes can be used. Image detection allows the device to set up the AR scene in relation to a specific image in the environment, like a printed QR code or a $1 bill. Since printers and dollar bills were both barriers to many users, we did not explore this mode of setup. The technology can also use plane detection. This approach can situate the AR objects more realistically in the real environment after having identified major flat surfaces. We used this approach in our prototype and found it to be slightly cumbersome, time-consuming, and too nuanced for many preschool children. We then explored tilt detection, which relies on fewer details of the real environment, but allows AR scenes to be set up more quickly and intuitively with minimal instruction and scaffolding needed. We found this trade-off to be the best approach for the preschool age group. In this case, the Gracie character instructs players to hold the iPad upright before they enter the AR part of the game, and the Tulip character appears in the upper left corner of the screen if the player needs additional coaching to move or tilt their device in order to set up the AR scene.
Challenge number 3. Focusing children's attention. When using a mobile device with AR, children can look and move anywhere. We had to design for that large, open space that children could explore, and our challenge was to help focus children's attention on the learning task at hand when they could literally go anywhere. Character gestures, on-screen arrows, and visual signs help children more easily navigate the AR space and stay on task. For example, here you can see the character Gracie pointing to the children's right, which accompanies audio directions, as well as a visual depiction at the top of the spatial relationship children are looking for.
The amount of encouraged movement or exploration conveyed to children by the app's design and the space occupied by the AR objects also made a difference. Too much movement by the player took them out of the AR scene and became distracting, as they were not sure what to look at or do. So, how big of an AR view worked best? We found that limiting the AR view to 180 degrees, specifically 90 degrees to the child's right and 90 degrees to the child's left, allowed children to stay focused on the task and play from a seated position when movement wasn't possible in a busy preschool classroom environment. But it also encouraged manageable movements and exploration within the AR space.
Challenge number 5. The size, number, and contrast of AR objects. AR objects' size and layout impacted children's ability to interact with the objects and understand the spatial relationships among them. At the same time, AR scenes needed to work in a wide range of real-world circumstances, such as colorful or cluttered environments, small or open spaces, players standing or sitting on floors or at tables, and a variety of others. Using tall objects gave the AR scene a sense of verticality, and keeping AR objects larger and implementing a border around the screen in the same style of the AR objects can help those objects pop more against brightly colored preschool classrooms. Don't clutter the scene with too many AR objects, as the AR world then becomes difficult to navigate, but rather give some space between the objects. For a before and after example, here you can see the AR fair scene with smaller assets and without the pink border, or as we like to call it, tulip vision. You can also see what the fair assets look like when we made them larger and added tulip vision in.
We wanted children to interact with the AR scenes, not just passively view objects. This active approach is what we think supports their spatial learning. Here are some challenges we encountered related to interactivity. First, tapping on the screen for interactivity would have been awkward for young children to do while simultaneously holding the tablet with both hands. Also, movement closer to an AR object was a lot of fun, but it introduced unavoidable technical bugs. To address these concerns, the team explored the use of a reticle, a circle that appears on screen as a visual aid to help children collect objects in the AR space. We found that using a reticle was intuitive and easy for children and did not introduce any technical issues. We would encourage others to use a reticle for interactivity. Also, consider movement and color in addition to the black and white to enhance the contrast between the real world and the AR scene.
Challenge number 7, cognitive load. AR experiences require a lot of cognitive effort for children. Open-ended and complex experiences prevented children from making key conceptual connections, like understanding the relationships between AR objects and a 2D map of those objects. To keep the cognitive load of gameplay low, tasks should be very straightforward and include step-by-step support for children as they use AR technology to learn. For example, in an early version of the app, children needed to remember the placement of several landmarks in AR, too many in fact, which led to a trial and error approach. In the final version, children identify the placement of one AR landmark at a time and then place that landmark on the map, allowing for a more manageable cognitive task and a more intentional approach by the child. In addition to carefully structuring the learning tasks and the game level designs, we found another way to help manage cognitive load. The game asks children to focus their view on the main character before the next task is given, so that children have a moment to center themselves and understand the flow of the game.
In conclusion, our observations of children's engagement with the app showed evidence of promise for AR technology in support of young children's spatial learning. But as usability impacts learning, the team identified design challenges to address in order to better support children's learning. Despite usability challenges, in early versions of the app, children were highly engaged by the novel AR technology and were motivated to complete the tasks, which is consistent with prior research.
We are encouraged by the potential of AR technology to support young children's learning, especially as the technology continues to advance. At the same time, there's still a lot to learn about how best to design and use this technology with young children to support their education.
For anyone who wants to check out the app, it will be available in the Apple App Store by the end of 2023, so keep an eye out for Gracie and Friends AR Adventures. In spring 2024, you will also be able to find curricular lessons for preschool classrooms and activities for families at first8studios.org. In the meantime, here's a preview of our final approach to the app.
Thank you so much for joining this showcase. Please feel free to reach out.